Hey guys, in today's lesson, we're going to look at the 6 trigonometric ratios. So we're kind of switching gears from what we've been doing with geometry and circles, and we're going to look at the 6 trig ratios. Now, you know 3 trig ratios from Math 2, and that is these 3 that I've listed right here: sine, cosine, and tangent. You know those 3. And the way you might remember them is by this, SOHCAHTOA. You might remember talking in Math 2 about SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, what do all of those terms mean? Well, if you have a right triangle, okay? So right triangle is denoted by a right angle. What I always tell students to do is to label the hypotenuse first. So in this triangle, we're going to go to the right angle, draw an arrow that points across, and that always points to your hypotenuse. So that side is my hypotenuse. Now, if I'm looking at this angle down here, so it's based on which angle you're looking at as far as what is the opposite side and what is the adjacent side. But let's say that I'm looking at this angle down here. So if I'm looking at this angle, if you will draw an arrow across from that angle, you are pointing to the opposite side. So that would be my opposite side. And then the side that's left is your adjacent side. Okay? Now, if I were to look at this angle up here, then my sides would change. That would mean that now this side down here would be opposite and this side over here would be adjacent. So based on which angle you're looking at is which one is opposite and which one is adjacent. But your hypotenuse will always be the side across from your right angle. So always label your hypotenuse first, okay? Now, like I said, these you should remember: sine, cosine, and tangent from Math 2. Sine, we abbreviate with SIN, that's a button on your calculator, opposite over hypotenuse. Cosine, we abbreviate with COS, and that is also a button on your calculator, and it is adjacent over hypotenuse. And then tangent, we abbreviate with TAN, and that is also a button on your calculator. It is opposite over adjacent. So these 3 are our new ones that you've never seen before. These 3 here: cosecant, secant, and cotangent. Now, the reason I have put these directly underneath sine, cosine, and tangent the way I have is because I want you to notice that they flip these fractions. So cosecant is hypotenuse over opposite. Sine was opposite over hypotenuse, and cosecant is hypotenuse over opposite. Cosine was adjacent over hypotenuse, and secant is now hypotenuse over adjacent. And then tangent was opposite over adjacent, and now cotangent is adjacent over opposite. So these are our new trigonometric functions that we're learning in Math 3: cosecant, secant, and cotangent. Okay? Now, we need to work some examples to show you how this applies. So it says, give all 6 trigonometric ratios for each triangle. Now notice, it's labeling an angle up here of theta for me to look at. And I'm going to write that out so you can see what it looks like. So it looks like that, and we say theta. It's a Greek letter of their alphabet, and we call it theta, okay? Now, always label your hypotenuse first. So find your right angle, draw your arrow across, and that is your hypotenuse. So that's my hypotenuse. Then label your opposite side. So here's my theta angle. Draw your arrow across, and that points to your opposite side. And that means the last side is your adjacent side. Okay? Now, you'll notice I need to come up with the ratios, but I only know that this is 3 and this is 5. Right now I have an x here. So we need to review something that you've learned prior, which is the Pythagorean theorem. These two legs squared and added together have to equal the hypotenuse squared. So that means that 3 squared plus x squared has to equal 5 squared. Okay, 3 squared is 9, plus x squared equals 5 squared is 25. To solve for x, we're going to subtract 9. That gives us x squared equals 16. To solve for x, we take the square root, which gives us x equals 4. So now we know that this side here is 4. Now we can use that to set up our trigonometric ratios, and we have to set up all 6 of them. So we're going to do sine theta equals, right? Remember, sine is opposite over hypotenuse. So opposite is 3 and hypotenuse is 5. Okay, cosine of theta is adjacent over hypotenuse. So my adjacent side here, that's the A, is 4 over the hypotenuse, which is 5. And then tangent of theta is opposite over adjacent. So my opposite here is 3, and my adjacent is 4. Okay, now I'm going to write these side by side so you can see what works here. So now we're going to do cosecant, and we abbreviate that with CSC. Cosecant of theta. It is hypotenuse over opposite. Hypotenuse is 5, opposite is 3, so this is 5 over 3. Notice these flipped. Sine was 3/5, cosecant is 5/3. Okay, secant, we abbreviate SEC. Secant is hypotenuse over adjacent. Hypotenuse is 5, adjacent is 4. So this is 5 over 4. And notice, these flipped. This one was 4/5, this one is 5/4. And then tangent, we need to do cotangent of theta. Cotangent is adjacent over opposite. Okay, adjacent is 4, opposite is 3. So this is going to be 4 over 3. And that will be your answer. I'm going to work some more examples in the next video, but let me know if you have any questions.